Oh! Hey, we're late.
Now we're talking. I'm not allowed to use one of those. Imagine that.
There, can you hear me? Yes. Hello! Yeah, they kind of gather in a little bit because there's a lot of road noise. These units that you're seeing across the way are all Cambrian sedimentary units. And you'll notice that according to the colors, we actually have three distinct zones. Each of those zones represent a different formation. At the very top, with the pinkish material, that is known as the Morgan Creek. Morgan Creek. In fact, all of these names, etc., are also in that write-up that I put together. It's up online. So the Morgan Creek on top with the pinkish. Then there's a sort of brownish tan in the middle. That's the Welge, W-E-L-G-E. And then at the bottom, the greenish material, that's the Lion Mountain, L-I-O-N mountain. And the Morgan Creek up on the top has actually been age dated at 560 million years. 516. We were to drill a little bit deeper right here, we would find underneath the underneath the Lion Mountain, we would be encountering the Hickory sandstone. So the Hickory is below us, can't see it. And this stuff is a little bit younger than the Hickory. And while we're here, we can notice a nice structural feature.
Oh yes, I can see it right there. The fault, you see it? The fault? Whoops.
Directly across from us.
I'm not a master of this.
Directly across the road from us is a nice little fault. It's.
You see it?
Oh, I see it.
See it right there?
Oh, I see it.
Oh, it's not nice. You notice there's an offset where the rocks on the right-hand side, looking
yeah,
up
you can
at
see that right
especially
there.
the Welge, the tan color. See how over on the right it moves down. And we see also that there's the motion within the Lion Mountain at the bottom.
Yes.
That's a nice little normal fault. Anytime we look at faults, we have to ask ourselves which is the hanging wall and which is the footwall.
Okay, so you're going up this.
It's a nice little normal fault.
And then you have to go hanging and footwall.
Hanging's on what, right or left?
Left. footwall because you can climb this thing.
Take a look again, guys.
What is the definition of a normal fault?
You have a hanging wall.
The hanging wall moves down relative to the footwall. Which side had moved down? The right. So that is now the hanging wall. The other side is moving up in a relative motion, and that is the footwall. Yeah, it would be good if you get a picture of that, and then you can see it nicely, and you can imagine putting arrows on it. And then
Here you can see the movement, but is that the actual fault where it's falling right here?
Like in the middle, you see it's almost like a triangular piece. Why is it broken? It appears to be broken on either side.
well, you notice that the other side is moving down, so that center piece
Moving up.
is up. Two sides on the outlet are moving down. And that piece in the middle that sort of has a keystone look, that is what we would call a horst, H-O-R-S-T. It has a pair of bounding normal faults. The one normal fault is dipping off to the right, and the other is dipping off to the left. Y'all get a good view of that?
Yes.
The green material down here at the bottom,
Oops,
this
sorry.
is what we would call a sedimentary mica. You're familiar already with the muscovite and the biotite. Those are the micas that you actually have in your sets. This is a sedimentary mica. It is a true mica. It has that sandwich look. And the green is present because it's ferrous iron. +2 iron. And this stuff is being produced by organisms which are living on the bottom of the sea. These organisms are chewing away on the sediment and then excreting this green material. So it is fossil poop.
Lovely.
Let's go touch it.
Let's go touch it.
Be one with the walk.
So this is the excretion of organisms that lived on the bottom.
The technical term would be coprolite.
Can you say that one?
That's poop. Coprolite. There are people who devote their entire lives to the study of coprolites. They say, boy, I like this schist.
Never ceases to.
Look at it.
I want you to look at the white zones that are in the green.
The white guy running across the street? What?
The white zones. You got a picture of them?
Those little white zones that you see are actually little lenses within the rock. You can think of them as, when the rock was forming, it was a trough, so it was a low point. That material is all fossil trilobite hash. the trilobite shell has been broken up by the wave action, and those pieces then accumulating within the lobes, the troughs. So you won't find whole trilobites in there, but you do see the pieces of the trilobites.
Oh, it is green. I don't like that green from. I thought he was gonna say that's the grass.
Now, if you look carefully, you see there some of it is a little reddish.
Yeah.
That's oxidation taking place right at the surface. You're oxidizing the Fe+2 to produce the Fe+3. You see all that chemistry stuff is really useful.
Never gonna use it. No, the green.
Look at
oxidation.
Fe+2 is green. And then when it oxidizes,
Did you get it?
I know, right?